Today, let's focus on evaluating a difficult but interesting indefinite integral. Integral x squared times arctan x over x squared plus 1 dx. Because the integrand looks complicated, so first let's break it up to two parts using the identity x squared over x squared plus 1 equals 1 minus 1 over x squared plus 1. So the given one becomes integral arctan times 1, we get arctan x dx minus arctan times 1 over x squared plus 1, so we get integral arctan x times 1 over x squared plus 1 dx. For the first integral, we can view arctan x as u, dx as dv, so here is v. So using integration by part, we get u times v, which is arctan x times x minus integral v, which is x times du. So equal to arctan x, which is 1 over x squared plus 1 times dx. For the last term, we know the derivative of arctan equals 1 over x squared plus 1. So we can write as arctan x times the derivative of arctan x dx. Now we can write x first. So x times arctan x. For the second term, we can write the top as half times x squared plus 1 prime dx. The bottom still x squared plus 1. You can verify that because the x squared plus 1, the derivative equals 2x times half, so we get x. Okay, so for the last term, we can write as arctan x d arctan x. So we get x arctan x. We can pull half out. Integral, the top can be written as dx squared plus 1 over x squared plus 1. For the last term, we can view arctan x as u. So there is integral u du. We know the antiderivative would be half u squared, which is arctan x squared plus c. Let's move on. So x arctan x minus half. At this point, we can use the well-known formula integral du over u equals ln absolute variable u plus a constant c. We can view x squared plus 1 as u, so we get ln u, so x squared plus 1. Here, we don't need the absolute value sign because x squared plus 1 always positive. So minus half arctan x squared plus c. That is the final answer.